Okay class, we're going to be doing 8.1, exploring logarithmic functions. The goal is to investigate the inverse of the exponential function. We know that the inverse of the exponential function y equals a to the power of x is also a function. It can be written as x equals a to the power of y, which is also the exponential form of the inverse. An equivalent form is y equals log ax. This is the logarithmic form of the inverse. The function is called the logarithmic function. Since x equals a to the power of y and y equals log ax are equivalent, a logarithm is also an exponent. The expression log ax means the exponent that must be applied to base a to get the value of x. For example, log 216 equals 4, since 2 to the power of 4 equals 16. For graphs, general shape of the graph of logarithmic function depends on the value of the base meaning a. If a is greater than 1, the function is going to be increasing. If a is in between 0 and 1, the function is going to be decreasing. The y-axis is always going to be the vertical asymptote for the function, for the logarithmic function, and the x-intercept is always going to be 1 for the logarithmic function. The domain of the logarithmic function will always be x of all real numbers, x greater than 0. Example 1, write the equation of the inverse of each exponential function in exponential form and logarithmic form. We know for the inverse we have to switch the positions of x and y, meaning if y equals 1 over 3x, we have to switch positions of x and y, making it x equals 1 over 3 y. For the logarithmic form, log is always going to be first, meaning always be log, then the base 1 over 3 here is going to be a subscript at the bottom, 1 over 3, and then x. For f of x equals 4 to the power of x, for exponential form, just like in example A, we switch positions of y and x, going from y equals 4x to the power of x, making it x equals 4 to the power of y. For the logarithmic form, same just like the other example, it's always going to be y equals log, then subscript, which is a base, which is 4 here, and then x. If we go to example 2, sketch the graph of each inverse function example 1. So we have the function being f of x equals 1 over 3 power of x. We know that the inverse can either be the exponential form or the logarithmic form. You will always get the same results. We know that a is in between 0 and 1, which is 1 over 3. Therefore, it's going to be a decreasing function. We know the x-intercept is 1. Therefore, we have a point right here. We know the y-axis is the vertical asymptote. So it's not going to be able to touch the y-axis. And since you know it's decreasing, the graph is going to look like this. If we go to example B, f of x equals 4 to the power of x. We know the inverse also from example 1 is either going to be x equals 4 to the power of y or log 4x. We know the x-intercept is always going to be 1. We know the y-axis is always going to be the vertical asymptote. But the difference here is 4 is base is greater than 1 here. Therefore, it's going to be an increasing function. So the function would look like this. And that's the end of the lesson.